black dwarfs come alive when a white dwarf star cools and it takes thousands of times the age of the universe for one to cool into a black dwarf star. And it normally happens like when a star, yellow dwarf like our sun, turns into a red giant, which our sun will be in like a couple of million years, a couple of billion, and then anyway, a red giant star eventually fights with its own gravity. Then it's like this, and soon it loses battle and ends up collapsing on itself like this. And guess what happens next? It explodes, like forming a nebula with a white dwarf star inside. Now, as I've already mentioned, that will take thousands of times the age of the universe to cool into a black dwarf, a dead, non-burning star. So this now we're going to talk about star life for other stars. So the closest red hypergiant or supergiant star to Earth is guess what? A star called Betelgeuse. Now before you might think it's juice, no. So juice, nope. So this is how we actually spell it. B-E-T-E-L G-E-O-C-E. It's like Beetlejuice. Then, so this star's life, I think, begins with a yellow giant star, like our sun, but just bigger. And then, it then, like our sun, it will go up, turn into a red supergiant star, like it is now, collapsing on itself when it's ready to go boom. Guess what will happen? Yes, it will go boom. And then, in the middle, leaving a neutron star. A star that has beams coming out of its north and south poles and vaporizing anything that gets in the beam's way. And isn't it crazy to know that just one tiny teaspoon of neutron star can just literally wipe out a whole solar system like ours? So, now things about galaxies. Every galaxy has a different pattern. Ours is a spiral galaxy. In the middle of almost every galaxy, there's a black hole. Black holes are dead stars that anything that comes within like a certain radius of the black hole, it pulls along and eventually destroys it. Then the final fact is that blue hypergiant stars, the closest ones in the Lagoon Nebula on the other side of the galaxy,